This is quicksort algorithm. The objective of quicksort algorithm is to sort an array, and the partition sub algorithm plays a key role in quicksort. The objective of partition sub algorithm is to give pivot element its appropriate position in the array and divide the given array into two subarrays. The left subarray contains elements which are smaller than the pivot, and the right subarray contains elements which are greater than the pivot. So today we'll learn how to partition an array without tracing the partition algorithm line by line. So here is an example shown in the Cormen book. So the initial setup is like this. Initially write down all the elements, then write down here P and J. Though P is not necessary, if you want you can delete this P. I should point to an invalid position because in algorithm the index starts from 1 and I is pointing to 0 position, and the R is pointing to the last element, which is the pivot element. Now the procedure starts like this. Compare the element which is pointed by J with the pivot. If this element is smaller than the pivot element, then increment I and exchange the value which is at index J. I mean to say the value at index I and the value at index J. You exchange the values. Exchange means swap. So in this particular case, 2 is less than 4. So we will increment I. Now I will point to position 1. J is also pointing to position 1. And if we exchange, there is no meaning because both are pointing to the same element. So 2 will be here. So there is no change in the array. And in the next iteration, one has to write I, which is pointing to 2, which is index 1, and increment J. So now J is pointing to index 2, or J is holding the value of index 2 and is pointing to element 8. So now next compare 8 with pivot. So always compare the value which is at index J. So 8, 4. Obviously 8 is greater than 4. If the value at index J is greater than, then increment only J without a second thought. So we will increment J. Now J is pointing to this 7. Again 7 is greater than pivot. Again increment J. So in the next iteration we will write J here. Now 1, which is at index J, is less than the pivot. In that case, increment I. So I will point to this place, then exchange the value which is pointed by J. So that is 1. So we will exchange the value, that means 8 will come here and 1 will come here. So in the next iteration we will increment J, but by that time these two values would have been swapped and I would have been incremented to this position. So now you can see 8, which is here, now here in this position, and 1 is here, and I also, I has been incremented and J also has been incremented. Now J is pointing to this. Again we will compare the value at index J, which is 3. 3 less than 4. This is also true. So we will increment I. So I will come here and we will swap the value which is pointed by j, that is 3. So 3 will come here, 7 will come here, and then we will increment j. So now you can see in the next iteration I is pointing to this, already swapped, 3 came here, 7 came here, j incremented. Again you compare, 5 is greater than y what, so only increment j. So now this is the last, so 6 which is greater than the pivot, so there is no need to increment j, because you can see the loop starts from 1 and it will go up to r minus 1. So now j is pointing to the last but one position. So in what will happen in the next I do not say iteration, because the loop is over here. So what it will do, now this is the scenario, you can see j is not there anymore, it has already reached here. So the next thing, increment I and swap the value with the pivot. So we have incremented, that is, it is pointing to 8, and we will swap this value with pivot. So 4 will come here, 8 will come here, and this is the final position of the pivot, that is 4, you can see. So 4, you see, whatever is present to its left, they are all smaller than this value, and all the elements which are present to the right, they are greater than 4. So this is the appropriate position of 4. So this way you can run the partition algorithm without tracing the algorithm. So this is a useful example. You should keep this example as a reference, so that any value, any series of values given, you can run partition algorithm and always choose the last one as pivot and run this way to find the appropriate position for the pivot. Remember the rules: initial setup, write down I here, then j here, then start comparing. If the value which is at index j is smaller than the pivot, increment I, then swap, and then increment j and write down the value in the next iteration. If the value is at index j is greater than the pivot, then only increment j. So keep on doing this till you reach the last but one. Once you reach the last but one position, increment I, then swap with the pivot, and your partition algorithm is over. And by that time, the pivot would have got its position. Thank you all.